July 26, 1943. Los Angeles was blanketed by a thick brown tinted gas. The citizens of the city thought that they were under attack, but this was the first time people encountered photochemical smog. People did not know what caused it back then, and if the people were still alive today, they would have wished that they had this video. In this video, I will be talking about an equilibrium process that is photochemical smog. I will be talking about what photochemical smog is, the chemical process behind it, and how it affects society. Smog is a type of air pollution, and it is a portmanteau of smog and fog. Photochemical smog is a haze found in the atmosphere caused by the action of sunlight on pollutants, consisting of high levels of ozone, nitrogen oxides, and several different VOCs, which stands for volatile organic compounds. VOCs can easily diffuse into the environment, as they are highly volatile, which explains it in the name, and can easily evaporate at room temperature. VOCs can contain carbon, oxygen, hydrogen, and chlorine, which can be naturally produced by plants, animals, forest fires, and volcano eruptions. However, the pollutants that impact the ecosystem the most are anthropogenic, which means that they come from industrialism and mostly cars, man-made. Primary pollutants, carbon monoxide, nitrogen oxides, sulfur oxides, particulate matter, and lead are produced. These lead to the production of secondary pollutants like sulfuric acid, nitric acid, and ozone. Sometimes the air is so bad that in countries in China, you need to get one of these masks. And these are actually a must if you go to China, since if you don't, you'll cough a lot and you won't be used to it. Now I will talk about the chemical process of photochemical smog. When we burn fossil fuels, nitrogen gas and oxygen react as a combustion reaction to form two nitrogen oxide molecules. The nitrogen oxide then reacts with the oxygen molecule in the air to form two nitrogen dioxide molecules. Then, energy from the UV rays in the sunlight causes the nitrogen dioxide to form nitrogen oxide and a free radical oxygen atom. The free radical oxygen can react with polysaturated fatty acids and membranes as well, which can lead to cardiovascular and inflammatory diseases. This free radical oxygen atom isn't like the normal oxygen we see, as that would be O2. This is only O. However, the free radical oxygen can react with another oxygen molecule, which you find in the air, producing ozone, or O3. Ozone in the stratosphere is beneficial to the environment, as it blocks out harmful UV rays. However, the ozone produced from this reaction is considered bad ozone, as it is tropospheric and causes a temperature inversion. This means that heated air goes to the ozone, hits it, and comes back, which means that it traps pollutants, and we will always be trapped with pollutants. The formation of photochemical smog can be summarized with this last reaction. Ozone and nitrogen oxide will form nitrogen dioxide and oxygen. The last reaction is an equilibrium and can go either direction depending on the temperature, amount of sunlight, humidity, pressure, and also the amount of different gases there are. Le Chatelier's principle states that if a change is applied to the system will readjust to cope with that change so that it is nullified. Photochemical smog can be summarized with this reaction. Ozone and nitrogen oxide will form nitrogen dioxide and oxygen. This is an equilibrium reaction and can go either way, depending on the temperature, amount of sunlight, humidity, pressure, and also the amount of different gas there actually is. Le Chatelier's principle states that if change is applied to a system, the system will readjust to cope with that change so that it is nullified. In this reaction, when there are more products than reactants, or if there is a lot more sunlight, the equilibrium will shift towards the left side and produce more ozone, as more UV rays can act upon the nitrogen dioxide. That is why in places with high temperature there is more sunlight, which means more UV rays can hit the nitrogen dioxide. A more humid environment also allows more ozone to be produced, as there will be more water in the air, or more oxygen in the air. A higher number of nitrogen dioxide means that more nitrogen dioxide can be broken up into ozone, so then the equilibrium can be established again. If one side goes up, the other side must go up. It's like the Katniss Everdeen reference in Hunger Games. You know, when we all die, you die, we all die, or something like that. Yeah. However, when there are more reactants, the equilibrium will shift towards the product side, that way, to produce more products to adjust to the change, and also due to the pressure. When there are more reactants, a higher pressure is built, and the molecules want to go to a lower pressure. To do that, they form more nitrogen dioxide, as this side will have less pressure. However, these molecules produced are all harmful, and it doesn't matter if there are more molecules on the left side or the right side, since these molecules can all impact the environment negatively. Favoring one side does not necessarily mean that it would help the environment. However, not all the nitrogen oxides will react with the ozone, as when hydrocarbons are involved, some of the nitric oxides can react with the hydrocarbons to produce formaldehyde, acrylane, and peroxyacetyl nitrate, or PAN, which is shown here as NO plus VOCs forms PAN. In this case, the nitric oxide reacts with the hydrocarbon instead of the ozone, which means less oxygen molecules are produced, leading to a higher ozone concentration, as they are not being reacted with. You would think that with more ozone there would be more reactants, which would potentially shift the equilibrium towards the right side, forming more product. However, there isn't enough nitric oxide reacting with the ozone due to the presence of hydrocarbons, as it is reacting with them. The result is both a high level of PAN, which is harmful to the environment, and ozone, which is also harmful to the environment. Equilibriums are good to understand, as it is the middle point where both the reactant side and the product sides are happy and have a balance. And balance in the environment is always good, as every component in the ecosystem is working the way it should. An imperfect equilibrium can tell you what to work on to improve the equilibrium, which is why understanding equilibriums are important. I believe that this process is vital to understand, as it closely relates to society and individuals today. Where more than 50% of the world lives in big cities, photochemical smog can be a relatable issue. Nitrates, which take place in photochemical smog reactions, are found in fertilizers. These end up in rivers and cause algae blooms, which deoxygenates water, destroying ecosystems. Nitrogen dioxide, when reacting with water vapor, produces nitric acid and can end up in the soil, making the soil release toxic metals, which can cause plants to lose nutrients. Smog can also lead to the cracking of rubber. It irritates your nose, eyes, throat, and causes several different health defects, such as asthma and cancer. To fix this problem, we have to understand the problem and the science behind it. Not all hope is gone, though. Legislation has been put to minimize these problems. For example, the Clean Air Act, which limits pollutant levels. New technology has also been developed to improve this problem. Catalytic converters and electrostatic filters have started to pop up in different places around the world. We can also grow more plants, like pine trees and juniper trees, as they metabolize nitrogen. I hope you enjoyed the video and learned at least something about photochemical smog. Thank you.